So we are ready in math to start chapter 5, which is fractions and factoring. So as of now, you should be able to, you should have passed all your other papers. So I'm behind on checking papers because I don't have them. And I'm also behind on Libby because we were out of school last week. So anyway, all right, or maybe it was the week before, I don't remember. All right, so we're going to go ahead and start chapter 5. And since it's fractions, I don't know where, I know Libby's pretty good with fractions, but she hasn't used them very much. So I thought I would just kind of walk you through this lesson and probably, maybe, perhaps even each one this week. I haven't looked to see. All right, so let's see. You took quiz 3 last time, so now that finishes us for 4, so we're starting on 5 today. So now they're going to start kind of going a little bit slower. Rather than having 2 and even 3 worksheets a day, you're going to kind of slow down, maybe just have about 1. So, all right, so let's look at our page in our book on chapter 5. It should be page 109, fractions and factoring. All right, so now we've reviewed those basic operations, addition, subtraction, multiplication, and division. Time to move on to fractions. In this lesson, we'll be taking a closer look at what fractions are and how they apply. Along the way, we'll take a quick look at some of the terms we use when dealing with fractions and a little bit of history of fractions. As we view fractions from a biblical worldview, we're going to see that, like the concepts we've covered so far, fractions are a way of describing God's creation and a real-life tool. Are you ready? Let's begin. All right, so the first part is defining fractions. Basically, what is a fraction? All right, the word fraction is used in many different ways in our English language. You're probably used to associating it with partial quantity. When you hear fractions, you think, okay, that means just a part of something. All right, and that is a fraction. For example, we say we cut a pie, and there's a round circle there pretending like it's a pie, showing to be a pie. You cut it into 6 same-size slices. Say that fast 5 times. We can look at those 6 slices individually as 6, but if we want to think of each slice as a part or a portion of the whole pie, we have to look at the pie. So each pie would then represent a partial quantity, a portion of the whole pie. We'd say that each piece is a fraction or a part of the whole. The word fraction has its root meaning in a Latin word, frangere, meaning to break. So in the case of our pie, we're breaking up the whole pie into 6 pieces. A fraction can thus be used to mean a partial quantity, no matter how we actually represent it. So in this sense of the word, let's flip the page. Now we're going to start putting numbers to it. Both 1/6 and 17/100ths. 17/100ths is another way of representing 1/6. And we'll get into that later, and you'll understand why later. So those would be considered fractions as they both represent a partial quantity. Okay, now look at that big gray box there with that arrow. Now that we've introduced fractions, we'll refer to non-fractional quantities 1 and higher as whole numbers. Now here's a note. The definition of whole numbers varies. Some definitions include 0 as a whole number. Notice that. Sometimes when you're looking at your math page, depending on what it is, sometimes when they say whole numbers, that includes 0. But for the sake of this book, it says, now that we've introduced fractions, we'll refer to non-fractional, that means regular numbers, quantities 1 and higher as whole numbers. So in this book, 1 up is considered a whole number, not 0. Now, fractions are a notation. Now, here's another term we're going to need to know. You're also probably familiar with associating the word fraction with a particular notation. Using this notation, and i.e., when it's in parentheses like that, it means example. Series or system of written symbols used to represent numbers, accounts, or elements. That's the definition of notation. Now, using this notation, we would represent 1 slice out of 6 as 1/6, and you read it 1/6. Notice that rather than just saying we have 1 slice, we have expressed the portion of the whole pie that the slice represents. fractions in this sense help us see how a quantity compares to a whole. The top number on top of the fraction is what we call the numerator. It tells us how many parts of the whole we're considering. The bottom number is the denominator, and it tells us how many parts are in the whole. So in 1/6, there are 6 parts to the whole, and we're looking at one of those parts. In 1/3, there's 3 parts to a whole. We're looking at one part. In 4/3, there are 3 parts to a whole, and we're looking at 4 parts. Now here's a picture to let you see what that means. Now there's 1/6. I'm on page 110. That 1/6 represents one part, 6 parts total. Okay, on the 1/3, the 1 represents one part. The 3, or the third, is 3 parts to the whole. Now look at the next one where it says 4/3. You see, that's kind of different. That's a bigger number on top than on bottom. We're going to learn about that here in a few minutes. 4 parts is what we're looking at, but there's 3 parts to a whole, which means there's going to be 2 of those. Okay? Now fractions give us an easy way to record quantities as parts or portions of others. For example, if you say that you've read 100 pages of a book, well, that doesn't really give us a clear idea of how close to the end you are. What if the book has 103 pages? Then you're almost done. But what if it has 500 pages? Well, then you're not almost done. But saying that you've read 100 pages out of 360 pages gives us a clear example of how close you are. So that would be 100 pages over 360 pages, because remember, 360 pages is the total number, and the 100 on top, that's the number we're looking at. That's the number we're considering. Okay? So that tells us what part of the whole you have finished. Likewise, 1/4 cup or 1/4 yard gives us a clear understanding of how the quantity relates to the whole cup or the whole yard. If you just say, well, I have 1/4. Well, you have 1/4 what? I have 1/4 of a whole. 1/4 of a whole what? 1/4 of a whole quart, or a whole pint, or a whole cup, or whatever it is. Okay. So there we have some terms for fractions, and we've also learned what the top and bottom numbers mean and why it's important to use those. All right, look at fractions where it says fractions or division. As surprising as it may seem, another way of looking at a fraction is a division problem. All right, so let's return. We're at the top of page 111. Let's return to our pie example. When we divide a pie evenly among 6 people, we're really breaking or dividing the pie by 6. So there's your pie. 1 pie divided by 6 pieces. We have a bit of a problem. How do we represent the result of 1 divided by 6? After all, 1 divided by 6 doesn't give us a whole quantity. So one way would be to use a fraction, and then you put 1/6. We've already seen how to look at this number 1 piece out of 6 pieces, the quantity of the pie that each person got. But we can also look at that as 1 pie divided by 6. The fraction line can be thought of as another symbol of division. So in fact, fractions can be used to show any division problem. Say we wanted to divide $10 among 5 people. So far, we've been representing that as just written horizontally, 10 divided by 5. But another way, though, would be to represent it as a fraction, and there they have it right in the middle of the page. $10 over $5, and they've written it out. $10 over, not $5, $10 over 5 people is the same as $10 divided by 5. You just say divided by. Your answer is 2, and that could be found by dividing or thinking of the whole as 5 and taking 10 of those parts. Fractions can be thought of as parts of a whole as well as division problems, because we'll get the same result either way. So let's look at that. Viewing 10/5, you can say, as division. All right, so there you've got 10 circles. All right, and you're dividing them into 5. Well, there's 2 in each pile. That's just plain division you learned in 3rd grade. All right, viewing 10/5 as part of a whole, each whole has 5 pieces. So you're going to draw 2 circles there, because you're going to divide those into 10. And, well, actually, I guess you wouldn't know that, but you would make 10 pieces, and you divide those into 2 wholes. So I'm sorry. No, you would make 10 pieces, 5 in each, because it's 10 divided by 5, or 10 pieces divided by 5. So that's how you would do it. You would make 10 pieces, 5 pieces 2 times, because you have to have 10. Did I confuse you? Because that confused me. In a way, the numerator, remember that's the top number, of a fraction can be thought of as a dividend and the denominator as the divisor. Now this thing on the very bottom of page 111 is really important. You might want to even write it down on a note card so you can remember. So 20 over 4, we can say, or 20 divided by 4, is the same thing as 20 divided by 4 using the line box that we've used. 20 is the dividend and 4 is the divisor. Same thing. Same thing. And you'll need to know this for future math purposes. Turn the page. All right, 112. Now here's something important up here in this gray box. Anytime you see one of those arrows pointing to a gray box, that means you need to kind of look at that. I just spilled coffee on the book. That's great. All right. While we use fractions all the time to refer to partial quantities and a particular way of representing them, it's very, very important to train yourself to also view the fraction line as a division sign. Doing so will help you understand the rules for working with fractions, and it will equip you for algebra and upper level math, which I will not be helping you with, by the way, if we make it. Okay, so just keep in mind that fractions are division. All right. Now we're going to look at how to pronounce 3 different ways we can pronounce fractions. This is important. It's going to be in your worksheet. Several ways to pronounce them. The first way is to do like 1/3, 2/3. Okay, it tells you there how to do it. Use ordinal numbers. Now exceptions are 1/2 as 1/2 or 1/4 as 1/4. So you can say 1/2 or 1/4, or you can say 1/4, or you can, of course, 1/2. All right. The second way to pronounce is to say this number over this number. I've been saying that too. 1/3 or 2/3. You can say that. That's my least favorite way of saying it. That's just the easiest, quickest way to say it when you're just looking at numbers. The third way is to use divided by. 1 divided by 3 or 2 divided by 3. That's the least used way that we do it. The way that I do it the most is going to be the first one, maybe the second one. But those are just 3 ways that you can pronounce, that you can say a fraction, and they're all correct. All right, now we're going to think of whole numbers as fractions. If you think of fractions as division, you'll have no trouble representing any quantity as a fraction, including whole numbers. For example, since dividing by 1 doesn't change the value, and it says see 3.5, that was section 3.5 earlier in the book, we can think of 6 as 6 divided by 1, which can be written 6/1. That means 6. Any whole number can be written as a fraction with the whole number in the numerator and the denominator of 1. You can, right here on this example, you can express 35 as a fraction. 35/1. That's what it means, because that's 35 divided by 1, which is 35. You can put any number over 1. Any number, any whole number over 1. 1,000,000 over 1 equals 1,000,000, because that's 1,000,000 divided by 1. That's 1,000,000. You can put 13 over 1. That's 13. So anytime you have a whole number and it says make this into a fraction, just put it over 1. That's all you do. All right, let's categorize these fractions, and then we'll look at a little bit of history. We have names to refer to different types of fractions. We call fractions that have equal or greater numerator, the numerator on top, than the denominator, improper. So anytime you find it, just like that 4/3 that we looked at, anytime the number on top is bigger than the number on bottom, that's improper. Now, a regular proper fraction is just where the top number, the numerator, is smaller than the denominator. Those are your normal fractions. That's what I call normal fractions. That's why we say proper, because a proper normal fraction is smaller on top, bigger on bottom. An improper fraction would be the other way around. Now, anytime that you have a number over itself. That's also considered an improper fraction, but here's a note. Any number over itself equals 1, because remember, that's divided by that number. So 4 divided by 4, I'm on the top of page 113. 4 over 4, 4 divided by 4, 4/4 is the same as 1 whole. So 1 million over 1 million equals 1 whole. Okay, and that's also considered an improper fraction. All right, now there's some fractions in history. I'm not going to read that. That's for you. You can't. I don't believe you're going to be quizzed or tested over these. If you are, I will help you when it comes to that. But it just kind of shows you how the ancient Egyptians, the Babylonians, the Greeks, and the Romans, how they represented fractions, some of the symbols that they used and things that they did. The Greeks, of course, had to use letters. That they always had to be different, or words. Okay, now let's look at the keeping perspective. This kind of keeps it in perspective. The middle of page 114. While often thought of as partial quantities or parts of a whole, fractions are also another way of representing division. They're an incredibly versatile tool. All right, now your assignment is going to be worksheet 5.1, but I'm going to go over each section with you right quick so that you'll kind of know what you're doing. All right, in worksheet 5.1, at the top where it says number 1, fraction rewriting, A through J, you are going to express these as fractions. Now, let me help you with a couple. So, on A, it says finishing 5 out of 20 math problems. Remember, the whole set, the whole amount goes on the bottom. The number we're considering, or the number that's different, goes on top. So your answer on A would be 5/20, 5 over 20. Okay? All right, so you can do those. Now look at G. 130 people. Now G and I are using one whole number, and they're wanting you to represent that whole number as a fraction. Remember, you put it over 1. Okay? All right, on 2, A through D, it doesn't want you to do the problems yet. It just wants you to rewrite those as a fraction. If you can't remember which number goes where, look back over at page 112 in your book at the not 112, 111 at the very bottom. Shows you how to rewrite those. All right, then on 3A, B, C, and D, it gives you a problem on the page that you've already done, and it's asking you to actually do the problem. So like 3A is go back to 1F and do the problem, and then 3B, go back to 1H and do the problem. C is 1J, and then on D, you go back to 2A and do that problem. So those just want you to actually do the problems. On number 4, term time, A through E, these are just going over some things that we read. So if you can't remember what it is saying, look back in your book, because these are all things that we talked about, terms of fractions and such. And then your questions, those again are written in your book. And then skill sharpening at the very bottom, those are just, it wants you to use the distributive property. Remember, the distributive property means you take that number on the outside of the parentheses. Don't do the parentheses first. You take the number outside and you multiply it by each number inside the parentheses, and then you add those up. If you're confused or you can't remember, you can either look back or ask me, and I'll give you an example. I want to see if y'all can do this without that first. Okay? All right, if you have any trouble, let me know, and I will be happy to help. That's all for today.